Hi, everyone. Thank you for attending today's webinar, Augment Your Expectations, Not Your Battery, How a Disruptive Technology is Changing the Way Utilities Deploy Storage. I'm Kelly Pickerel, editor of Solar Power World, and before we get started, I wanted to go over a few housekeeping items. You can view the slides for today's presentation in the resource window on your screen, and please submit any questions related to today's webinar in the Q&A window. If we do not get to your question, our presenters may reach out to you afterward. Finally, if you're watching this webinar on demand, you can still use all of these features, including sending questions to our presenters. So let's get started with today's webinar, Augment Your Expectations, Not Your Battery. Today, we will hear from representatives at Enervenue and Storlytics about grid-scale energy storage and alternatives to traditional lithium-ion technology. So now I will turn things over to Jamil with Storlytics.
Thanks, Kelly. Hello, everyone. My name is Jamil Hussain. I'm the Chief Technology Officer and co-founder of Storlytics. I'm actually filling in position of my colleague, Momen Yassi. He had some technical issue with his audio and we were not able to resolve that in time. So with no further ado, let's go ahead and get started with the discussion. So today, we're going to talk about the Storlytics platform as well as the Enervenue technology. And we will share some of the case studies that we have done to see how the Enervenue technology performs against typical tier one lithium suppliers. So first part of the presentation is going to be about the Storlytics review and the typical process of modeling energy storage system and what are the key factors you need to take into account in the design process of energy storage project, and what really impacts your total cost of ownership. And then we'll have Chad presenting about the Enervenue technology. And the last part of the presentation, I'm going to go through some of the case studies that we have done and performance benchmarking between Enervenue and lithium technology. So with that, first we'll start with a little bit of introduction about myself and Storlytics. So like I said, my name is Jamil Hussain. I'm one of the co-founder and the Chief Technology Officer here at Storlytics. My background is in power system engineering, and I have almost a decade of experience working with utilities, universities, research organizations. So really, where Storlytics started as a collaboration between National Lab and universities back in 2016. Both myself and my co-founder had a lot of experience with the solar industry, where we were doing a lot of designing and modeling of solar projects, and what we have been using PV system a lot in those design. But as we transition to energy storage design, we see that there is a gap in the market where you do not really have a common simulation platform or modeling platform that focuses on energy storage sizing, your overall plan design of that aspect. So typically, supplier, each integrator have their own operating practice, but the assumptions, the modeling details, everything varies from models to models. So we saw that there was a real gap in the industry on a common simulation. And that's what was the primary motivation for us to start working on Storlytics, as we see that to be the biggest system of energy storage. So we launched our first version in Q3 of 2021, and then till date, we have got over more than 140 plus users in more than 10 countries. Here in the picture, you can see a template of or a screenshot of our software platform. I'm going to go into that a little bit more in the later slide. Okay. So let's get into the typical or the design process that we adopt in designing an energy storage project. So we see it as a two-pronged problem, right? So first stage, you have to understand your need. So let it be a non-oil alternative, if you're participating in a market environment, a total agreement, or can be ancillary services. So you really need to look at what are the driving factors of the need perspective. And then if you're trying to meet all this application, what your profile should be looking like. So that's kind of part of the first stage where you introduce the profile that your project needs to meet. And the second part is that, okay, now you have a project profile or use case battery dispatch profile that you want your project to meet. And there are some certain design parameter like your project life, things like that. So the question then becomes, how do you determine best technology for your particular project? And how do you optimize your overall system design? So that's the second part. So you need to do an upfront study first to determine what are the application you'll be doing and what your use case needs to be. And then you need to do a detailed study for that specific application to determine which technology is best for your need. So in that vein, when you're talking about choosing the right technology and the OEM for your specific use case, right now, if you look into the current marketplace, there's not a lot of focus on a specific use case, right? So you typically get a requirement around 365 cycles per year. Now, whether that's like an 365 cycles, like a deep discharge, like an energy arbitrage, so one cycle per day, or it's more like ancillary or microservices where you're not doing a full cycle, rather a lot of intermittent cycles you are doing. So all this has different impact on degradation and battery size. But right now, what the market is doing, they are using very generic assumptions on the use case and then trying to choose the best. Because the supply chain market is very constrained, the storage market is constrained, they're trying to pick the battery that they can get their hands on. So not really focusing on the use case itself. So in the process, you are leaving a lot of value on the table. So where the storage platform comes in, that it helps you to really find the best technology for your particular use case, allows you to compare different technologies. So you can really see for your particular use case, which is the best technology. So for example, like if you have a microgrid kind of application where you need to store energy for a longer duration time. So battery technology with cell discharge might not be the best. The high cell discharge might not be the best. But if you are having a very high cycle application, then you need a technology which has a better degradation performance. So things of that nature you need to consider and really the impact of that is different based on the use case. So that's why it's important to really have a simulation platform that helps you to find the right technology for your right use case. And eventually all this comes down from a project financial perspective is a total cost of ownership, right? So you need to look at what is the total cost, what the full project like. So on the upfront cost, just look at CapEx, some technology might be more cheaper or more cost effective upfront, but then those might have larger costs throughout the operation. So like augmentation multiple augmentation cycle might be needed. You might need to do replenishment. So that comes into the picture. As well as there are costs for maintaining the performance gap, right? So if you have to maintain a firm capacity for a certain period of time, you need to pay for that as part, or also might need to sign up for some long-term service agreement, pay for that. So that adds to your own, as well as if you have a technology with a higher line trip efficiency, that adds to your energy loss. So that will need to be accounted as part of your project financial as well. So it's important to look at not the upfront cost, but rather the whole cost of ownership. And then the question becomes, okay, that's understood. So we need to look at the total cost of ownership. So what are the factors that impact the total cost of ownership? So the way we see it, there are two main prongs, right? So you have the technology itself. So there are certain characteristics of your storage technology that impacts different aspects that eventually impacts your bottom line, which is the cost of ownership. And then there are certain characteristics of the use case that also impacts. So if I go into the storage technology, you got to look at the cycle life, the calendar life, the battery that directly impacts, your initial overbuild factor or how many augmentation cycle you will need. So that has an impact on your overall cost. Then you have your round trip efficiency, your self-discharge. So that impacts your overall energy loss. You have to have your operational constraint. So different technology has different operational constraints. Some technology, and that also applies to a system level, right? So if you If you really cycle a module or a rack, maybe you can do 0 to 100% no issue. But if you look at a system level, you look at the interconnection between different racks, the voltage drop, the management of voltages, those becomes issue. So on a system level, you might not be able to get 0 to 100%. So sometimes it's limited. So those kind of operational characteristics you got to take into account from technology perspective. Then you have the auxiliary load requirements. Like for lithium ion, we know that you need a very temperature control environment to maintain the right environment for the batteries to operate. But there are other non-lithium technology where you don't need any kind of active temperature management. But toward those technology, you might see some power or energy derating as the temperature varies. So you got to understand those features as well. And then you come to the use case side. So what's the C rate? I mean, you had a max C rate, so maybe a 4-hour, 2-hour system you look at. But what if, you're not going to operate the system at like C by 4 or C by 2 the whole time, right? Your C rates are going to vary. So understanding the composition of your use case profile, like how many times you're doing energy arbitrage, how many times you're doing a frequency regulation, that's going to have an impact on your C rate, and that directly impacts your degradation. You have your total throughput. That's something you got to look at. So right now, industry is pretty comfortable with 365 equivalent cycles, but that throughput amount can vary depending upon your need. You have the depth of discharge. So whether you're cycling from 100% to 0% all the cycles or between 40 to 60, that has an impact. And that can significantly impact your degradation. You have to look at your average state of charge, the resting period between cycles. So all these each case specific factors also have an impact on your overall bottom line. So these are some of the things we're going to look at in our comparison between Enervenue and the lithium system. So we looked at all these aspects, and we're going to present some of our findings in the later part of the presentation. With that, now I'm going to pass it to Chad to give us an overview of the Enervenue system.